This video is about review for vectors. The plane π1 contains the points P, Q, R. Find the Cartesian equation of the plane containing P, Q, R. According to the formula booklet, we know there are three types of equations of a plane. Cartesian equation of a plane is this. We do know D equals A dot N. First of all, we need to work out the normal vector. If this is the plane π, the normal vector N, we have 3 points P, Q, R on the plane π1. These 3 points can form 2 vectors. And a normal vector will be the cross product of these 2 vectors on the plane. Check PQR. The coordinates for Q is an easy number, QR and QP. Use the easy method to figure out the vector QR. R is the ending point, 2, 0, negative 4, minus 0, 1, 1, 2, negative 1, negative 5. For QP, 1, 6, negative 7, minus 0, 1, 1, equals 1, 5, negative 8. So the normal vector equals QR cross QP equals 2, negative 1, negative 5 cross 1, 5, negative 8 equals, cross out the first row, negative 1 times negative 8 is 8, minus negative 5 times 5 is negative 25, so plus 25. Cross out the second row, 2 times negative 8. Remember, we have a negative sign, negative 16, minus negative 5 times 1, plus 5. Cross out last row, 2 times 5 is 10, minus negative 1 times 1 is negative 1, so plus 1. 33, positive 11, positive 11. Since this is a normal vector, we can take a factor out, 3, 1, 1. The equation of a plane using normal vector R dot 3, 1, 1 equals, A is a position vector. You can use any of PQR. Since Q is an easy one, I will use Q, 0, 1, 1 dot 3, 1, 1. We know the R means X, Y, Z. So we have 3X plus Y plus Z equals 0 times 3 plus 1 times 1 plus 1 times 1. Organize 3x plus y plus z equals 2 will be the equation of the plane π1. Let's go to B. The Cartesian equation of the plane π2 is given by x minus 3y minus z equals 3. Given that π1 and π2 meet in a line L, verify that the vector equation of L can be given by this equation. we will change this equation into parametric form. X equals 5 over 4 plus 1/2 lambda. Y equals lambda. Z equals -7 over 4 minus 5 over 2 lambda. Then I need to substitute into the equations of pi1 and pi2. 3 times 5 over 4 plus 1/2 lambda plus lambda plus -7 over 4 minus 5 over 2 lambda equals distributive property 15 over 4 plus 3 over 2 lambda plus lambda minus 7 over 4 minus 5 over 2 lambda. Cancel lambda equals 8 over 4 equals 2. 8 means L is on the plane pi1. Let's go to pi2. Still do the substitution. 5 over 4 plus 1/2 lambda minus 3 times lambda minus -7 over 4 minus 5 over 2 lambda. Simplify. Distributive property 5 over 4 plus 1/2 lambda minus 3 lambda plus 7 over 4 plus 5 over 2 lambda. Cancel. 12 over 4 equals 3. So we verified the vector equation of L is the intersection line for pi1 and pi2. Let's go to C. The Cartesian equation of the plane pi3 is given by ax plus by plus cz equals 1. Given that pi3 is parallel to the line L, show that a plus 2b minus 5c equals 0. Let's draw this diagram. We know the normal vector of pi3 is perpendicular to the direction vector of L. This is a direction vector. Let's label direction vector of L as a D. Since the normal vector of pi3, let's label as N3. It's perpendicular to vector of D, which means normal vector dot vector D equals 0. The normal vector for pi3 is A, B, C dot. The direction vector of L is 1/2, 1, -5 over 2 equals 1/2 A plus B minus 5 over 2 times C equals 0. Times 2 both sides. A plus 2B minus 5C equals 0. Let's go to D. Consider the case that pi3 contains L. Show that 5A minus 7C equals 4. If L is on the plane pi3, this position vector will be on the plane pi3. Now let's do the substitution. A times 5 over 4 plus B times 0 plus C times -7 over 4 equals 1. Simplify. 5 over 4A minus 7 over 4C equals 1. Times 4 both sides. 5A minus 7C equals 4. For E, Given that pi 3 is equally inclined to both pi 1 and pi 2, determine two distinct possible Cartesian equations for pi 3. We do know the angles between two planes equals the angle between two normal vectors of the two planes. For pi 1, the normal vector is 3, 1, 1. For pi 2, normal vector equals 1, negative 3, negative 1. For pi 3, normal vector equals A, B, C. Let theta be the acute angle between vector n1 and n3, and alpha be the acute angle between n2 and n3. According to this formula, we do know cosine theta equals absolute value n1 dot n3, length of n1 times the length of n3 equals 311 dot ABC square root. 3 square is 9, 1 square is 1, 1 square is 1, times A square plus B square plus C square. So we get 3A plus B plus C all over square root 11 times square root A square plus B square plus C square. Cosine alpha equals absolute value n2 dot n3, length of n2 times the length of n3 equals 1, negative 3, negative 1 dot ABC square root. 1 square is 1, negative 3 square is 9, negative 1 square is 1 times square root A square plus B square plus C square. That equals A minus 3B minus C all over square root 11 times square root A square plus B square plus C square. Equally inclined to both pi 1 and pi 2 means cosine theta equals cosine alpha. You notice that the denominators are the same. So we get 3A plus B plus C absolute value equals A minus 3B minus C. Get rid of the absolute value. 3A plus B plus C equals plus or minus A minus 3B minus C. 3A plus B plus C equals A minus 3B minus C, or 3A plus B plus C equals, get opposite of A minus 3B minus C, negative A plus 3B plus C. Then move the terms to the left side. Combine like terms, 2A plus 4B plus 2C equals 0. Divided by 2 both sides, A plus 2B plus C equals 0. This one, move everything to the left side. 4A minus 2B equals 0. Divided by 2, both sides. 2a minus b equals 0. Then use the equations from C and D to get two systems of equations. The first system of equation, we got A equals 4 over 5, B equals negative 2 over 5, C equals 0. For second system of equations, A equals negative 2, B equals negative 4, C equals negative 2. The possible Cartesian equations for pi 3. Ax plus by plus cz equals 1. 4 over 5x minus 2 over 5y plus 0z equals 1. Organize times the 5 of both sides. 4x minus 2y equals 5. For the second equation, negative 2x minus 4y minus 2z equals 1. In this way, we got two possible Cartesian equations for pi 3. Let's go to F. The point B and the plane pi 2 is given by this. Find the shortest distance from B to the plane pi 2. Let's draw the diagram. This is pi 2. This is B. We need to figure out this Q. For the pi 2, we have a normal vector N2. The vector BQ is parallel to normal vector N2. In this way, we can write down the equation for the line BQ. R equals position vector is B, 1, negative 2, 0, plus, let's use T times. Normal vector for pi 2 is 1, negative 3, negative 1. We will change this equation of the line BQ into parametric form. X equals 1 plus t, y equals negative 2 minus 3t, z equals negative t. Then we substitute into the equation of pi 2. X is 1 plus t minus 3 times negative 2 minus 3t, then minus negative t equals 3. Distributive property, then combine like terms. 1 plus t plus 6 plus 9t plus t equals 3. 11t equals 3 minus 7 is negative 4. So t equals negative 4 over 11. Get the x equals 1 minus 4 over 11, 7 over 11. Y equals negative 2 minus 3 times negative 4 over 11. That equals negative 2 plus 12 over 11 equals negative 10 over 11. Z equals 4 over 11. Coordinates for Q, 7 over 11, negative 10 over 11, 4 over 11. So the distance between B and Q will be the shortest distance. 7 over 11 minus 1 square plus negative 10 over 11 plus 2 squared plus 4 over 11 minus 0 squared. Go to calculator. 1.21. Let's go to B. Find the reflection of the point B in the plane pi 2. This will be B prime. We will double this t and then figure out x, y, z will be this B prime. T prime equals 2t. That is negative 8 over 11. So for x equals 1 minus 8 over 11 equals 3 over 11. For y equals negative 2 minus 3 times negative 8 over 11 equals negative 2 plus 24 over 11 equals 2 over 11. Then z equals negative t is 8 over 11. So the reflection point of B prime is 3 over 11, 2 over 11, 8 over 11.